Hello everyone, and welcome to part 2 of Algebra 2, Lesson 7.1, Exponential Functions, Growth and Decay. In this video, we're going to talk about how to write a growth or decay function based on information that's given in a word problem. So the first thing that we need to look at is the actual model we're going to be using for growth and decay. The model that we use is this one right here. You have A of t, which is the final amount after a given time period has elapsed, equals the initial amount, that's the initial value of whatever object it was, or the initial amount of stuff you had, times 1. Now, the plus or minus depends on whether it's increasing or decreasing. So if it's an exponential growth, you'll use plus. If it's exponential decay, you're going to use minus. The rate of increase, generally they're going to give you a percentage, and you need to change that percentage to a decimal. And then it's to the power of t, which is the number of time periods. It's the time that's elapsed. And usually t is our variable because remember, this is an exponential function. So t is the variable. You can also tell that because right here, that is the variable that's in your function notation. So let's take a look at a word problem where we would need to actually write this model and then use this model to find a value. In example 2, it says that Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. It says use a graph to find when the value of guitar was $60,000. So step 1 to this question is actually to use our model to write a function. Notice my initial amount is 12,000. Okay, the value is increasing by 14% per year. So using that model, we will have 12,000 times, in parentheses, 1 plus 0.14, close the parentheses, to the t power. And this is what it would look like. Okay, so this is my function. Now, they want us to use a graph to find when the value of the guitar was $60,000. So we're going to do this on our graphing calculators. Those graphing calculators, what we do is we graph this function in the y equals menu, and then what we're going to do is we're going to use the table to find out when it was $60,000. So as you can see, I went to the y equals of my calculator and I put in the function that I wrote earlier. And then what I did is I hit second and then graph, and that takes you into the table. And all I did was I scrolled down the table until I found where it changed from 57,815 to 65,909. So it's somewhere in between 12 and 13. So we know that the guitar will have a value of $60,000 during the 12th year, or during the year 2012. So my answer for this question would include both the function and my conclusion that it would be during the 12th year, which is during 2012. Let's take a look at another example very similar to this one. In example 3, it says the value of a truck bought new for $28,000 decreases 9.5% each year. Write an exponential function and graph the function. Use the graph to predict when the value will fall to $5,000. So our initial amount is $28,000. We're decreasing at a rate of 9.5%. So in my function, $28,000 is the initial amount. I do 1 minus because it's decreasing. And then 9.5% as a decimal is 0.095. And it's to the t power. Now, to graph it, I'm going to use my graphing calculator again, and I'll just type this in the y equals menu, and then I'll use the tables to figure out what it is that they wanted me to find out. So here's my y equals menu. It shows the function. Then I hit second and graph to get into the y equals menu. To get into the table menu. And I just scrolled down until I saw that it went from $5,130 to $4,643. So it's during the 17th year it will fall to the $5,000 value. So that is the answer to that part of the question. So that's it for this video. Let me know if you have any questions or if you need help with anything.